two parts. It has a network part and a host part. So there are certain number of bits which show which network the address, the machine with this address belongs to. In other words, the network part, all the machines that are part of the same network would have this part the same. So all the machines that are on the same network will have the same bits in this field. The host field is telling what is the host number for the machine on this network. So these will differentiate machines from one another that are part of the same network. And so which network the machine belongs to, which machine is that? So each machine will have a number, let's say 1, 2, 3, 4. How many machines can we have on the same network? So this is a local area network, and this field will tell us the machine number that is part of this network. How many can we have? So there is what? 1, 2, 3, 4, 5, 6, 7, 8 bits here for the host part. So how many hosts can we represent with 8 bits? Is very good. So it's just 2 to the power of 8. So that's 256. So this network cannot have more than 256 hosts. And this is where the problem came from with the wasted IP addresses. Because the way we originally assigned these addresses is we divided them into classes. So each class has a different number of bits that is available for the host. The one we were looking at was a class C because it had 8 bits for the host. But we have other classes too, like in class A, it will have, how many bits is that? 24. That's a lot of hosts. Class B has 16 bits. That's 2 to the power of 16. How many hosts is that? $65,536 minus these 3 bits here, because these are reserved. Anyway, that's close to 65,000 So in the beginning, when these addresses were assigned, all the companies requested a Class B address because they were dreaming that they're gonna have 65,000 employees and each one will need its own IP address for the computers that are part of their network. And when we gave them one of these addresses, we gave them a unique combination of numbers for the network port, and they took it, but they never used all the costs. I mean, Microsoft Corporation had 70,000 employees. There are a couple of bigger ones that had that, but most of them didn't have it, so they ended up wasting addresses, and now we're out of addresses.
So once one's assigned, it can never like be used again for anything else? Like, how's that work?
So now what they do is, instead of giving them this one big address, they will give them a bunch of Class C addresses, depending on how many calls. So if 256 is not enough, but 65,000 is too big, they will just give them 4 or 5 Class C addresses.
What I'm asking is like, so why are they lost, the ones that are assigned that weren't used?
Because the Class B address, the numbers in the network part are fixed, right? These numbers are available, the cost part. And they are 65,000 plus of them. But let's say they only used 10,000. The other 55,000 are not used.
And why can't somebody be given like that address that's not part of that network?
They can, but in the beginning, the companies requested them and it was given to them. They didn't think about this problem.
No, but like, I'm saying aftermath. Like, so the company has all these addresses not used. What happened to somebody else is given one of those addresses? Can it not be reassigned? Like, why? And so if not, why not?
Like if they have to change all of the addresses of all the machines, most of them wouldn't do something like that. They gave it to them and they took it and didn't use it, and that happened massively. And
So could somebody not just use it then? Like, if it's not being used, why can't somebody like?
because they can't take it from them because this is their network. The network part is the same for these guys, for all the machines on that network. And so what they will do now is they will take a Class C address and give them, instead of 1, like 5 or 6 or 10 of them, depending exactly on the number of ports that they need.
So when things are routed, it looks for like location of network, no matter like. So it'll always go for that location.
Yeah, that's exactly what the routers are doing. So when the router gets an address, what it does is it takes this subnet mask. The subnet mask has 1s for the network part and 0 for the host. So what the router will do, it will take the subnet mask and end it with the IP address. So it does a Boolean AND operation. When it does that, the host part is zeroed out, and the only thing that's left is the network part. So then it compares the address with the addresses that it has in its routing table, and if it matches the network part of any of those, it routes it onto that network. If it doesn't match, it routes it to default route.
Could you not technically just have like the network part not even in that network? And it's, why not if you can't? Like, say if you just had the same network first, however many bits the network part is, in somewhere that's not even a part of. So you have like a network somewhere, and somebody else just happens to have that exact same first, however many bits. It's the same as the other network. Why can't that happen?
It can. That's when you would create subnetworks. That's called a subnet. So, for example, you will take the network part and remove a few bits from it. So then you would have a different network part. And these few bits can be used for creating subnetworks within the network itself.
What if it's like something taking the same IP as something else?
That's not allowed. Now we have an international organization that controls the assignment of the IP addresses in the world, and we never have two machines with the same IP address. Like, because the IP address is the address that uniquely identifies this machine in the world. This is like our post office address. We can have two people living on the same street with the same number, but in a different city. That differentiates them. And this first part is the same, but the city is different, the zip code is different. Otherwise, if we have one house here and one house in another city, and they have the same address, how will the post office know where to deliver the package? We can't do that. So, same situation here. Each machine has a different unique IP address, and that is controlled on government level. Now, I want to show what these routers are doing very